Hey students, today we are going to discuss about the heating and cooling curves. Explaining phase changes by heating and cooling curves by Ms.Saamiyah J. Qureshi. But first, subscribe to my channel. Don't worry, they are not difficult. I'll make it easy for you. Let's start the video. Hey chemistry explorers, welcome back to Simple AlChemy. Today we are diving into something super cool and hot at the same time. We are talking about heating and cooling curves. Don't worry, I'll make it super simple and fun for you. Let's go. First of all, what happens when you heat a solid? Imagine you are heating a solid like chocolate or ice. What happens? At first, the temperature rises slowly. The solid gets warmer until boom, it starts to melt. But guess what? Something surprising happens. The temperature stops going up. When you heat the solid, temperature rises and the time comes when the line becomes straight and it starts rising again. When the line becomes straight, that's melting. What happens when you heat a solid? Yes, while it's melting, the thermometer stays the same. Why? Because all the heat is busy helping the solid change into liquid, not making it hotter. This flat part on the graph is called a plateau, where the temperature stays constant. It doesn't increase, so it means a phase change. Once all the solid is melted into a liquid, the temperature starts to rise again. And if you keep heating, guess what? The liquid starts to boil. That's when it turns into a gas like steam or water vapor. Again, the temperature pauses. All that heat energy is now being used to help the liquid escape as gas, not to raise the temperature. So, heating curves have two flat lines, one at melting, one at boiling. This is a heating curve. Now, let's cool things down. Imagine doing the reverse. You take a hot liquid and start cooling it. What happens? The temperature goes down, down and down until it reaches the freezing point. Then it stops again. All the heat energy is now being released as the liquid slowly turns back into a solid. That's freezing. The line becomes straight again. That's the freezing point. Freezing. Think of water turning into ice slowly, beautifully, molecule by molecule. That gives us a cooling curve. A graph where temperature drops and then stays flat while freezing. Let's visualize it. This graph shows how the temperature drops, pauses while freezing, then drops again as the solid gets colder. So key idea, temperature stays the same during the phase change because heat energy is being used or released to break or form the bonds, not to change the temperature. So the temperature stays the same. Why is this useful? So why do scientists love these graphs? They help measure melting and boiling points. They show us how substances behave when they change states. They explain why ice melts at 0 degrees Celsius but doesn't instantly turn into water vapor. Let's wrap it up. This is a heating curve and this is a cooling curve. In heating curve, the temperature rises, it stays flat at melting, then it rises again, and then it stays flat at boiling. In cooling curve, temperature drops, stays flat at condensation, drops more, stays flat at freezing. These are heating and cooling curves. Easy, right? Curves go up when we heat, down when we cool, and they pause when the matter changes state. So that's it. Thanks for learning with me. I hope you enjoyed exploring heating and cooling curves. They're so simple. Don't forget to like, subscribe, and hit the bell so you don't miss our next fun chemistry lesson. Thank you so much for liking the video. I'll see you in the next class and the next video. Thank you so much. Bye-bye.